Good day. This is carrying on from the last PowerPoint where it talked about major hydroxide for balancing more complicated half reactions. And so we're going to do 6 examples, and I'm going to do them 2 per video. So it's 3 little videos on how to do this. So remember, we have major hydroxide, major atoms, balance the oxygen, balance the hydrogen, and balance the electrons. So our first question says dinitrogen oxide becomes nitrogen gas, and you can see I've typed these out instead of writing them, so hopefully you'll be able to follow along and copy this out. Here's our dinitrogen oxide, and there's our nitrogen. Got to remember it's diatomic. Now we look at this, and the major atoms are balanced, so it's balancing oxygens, and we do that by adding water. We had 1 oxygen here, and adding 1 water adds 1 oxygen. Of course, that makes some hydrogens, 2 hydrogens here, and so we got to balance the hydrogens by adding H+. And so that's what we do. We had 2 H's here, so we have to add 2 H+. So it's all balanced in terms of atoms, and now we have to balance in terms of charge. On this side, the total charge is 2+. 0 from this beast, and 2 times 1 plus is 2+. This side is 0, so we have to bring the left side down in charge down to 0, and we do that by adding 2 electrons, and that's it. We know we're done because it said an acid, and we have H+ rattling around there. Let's go on to B. So here we have nitrate ions, and if you can't remember what they are, you look them up on your table of complex ions. Same for nitrate. These names actually have to do with oxidation states. And so we have NO2 minus become an NO3 minus. And that was a hiccup. Let's try to hit the right button. So there we are. NO2 minus becomes NO3 minus. And the first thing is the nitrogens are balanced, the major's done. O2, O3, the oxygens aren't balanced, so we got to add some waters. And we add the 1 water. Now we have 3 oxygens left, 3 oxygens to the right. And now we are going to balance the hydrogens. 2 H pluses, common theme here. And we add 2 electrons. Why? Well, on this side we had 1 minus on the left. And here we had 1 minus, 2 plus is 1 plus. So we have to take our 1 plus down to 1 minus, and 2 electrons does the trick. Now, that's balanced in acid. But this question wants it balanced in base. Basic solution. So, this is a balanced equation. It's a half reaction. So when we add OH minus, we have to add the same amount to both sides. We see we have 2 H pluses, so we're going to add 2 OH minuses to both sides. So we add 2 OH minus there, 2 OH minus there. Because it's already balanced, we want to keep it balanced. Now, every time an H plus gets together with OH minus, it makes a water. And so if we have 2 H pluses and 2 OH minuses, they're going to make 2 waters. And what we see is everything's the same, except we now have the 2 hydroxides here, and these 2 beasts came together to be 2 waters. Now often we like to show this. We cross out that 1 H2O, and we cross out the 2, leaving behind a 1. But my computer is not really set up for that. But 1 water becoming a 2 is the same as no waters becoming 1. And that is done. That is now balanced in base, and we have the hydroxides. And always with these things you should go through and check that things are actually balanced. 1 nitrogen, 1 nitrogen. 2 oxygens and 2 oxygens is 4. 3 and 1 is 4 oxygens. 2 hydrogens, 2 hydrogens. Here we have 3 negative, and there's 1 minus, 2 minus, 3 minus. So it all checks out. So that's A and B. We're going to move to C and D.